All right, the Astrolabe and how it ties into the populations giving in the biblical book of Numbers is what we're going to talk about today. I got to thank Tina at the Fight for Truth. They got me down the path of learning this Astrolabe instrument. So thanks for that. This is quite the fascinating tool, and I've been playing around with this website right here that she turned me on to, right here, this alexboxer.com Astrolabe. Very cool tool. Just for those that maybe aren't familiar with the Astrolabe, we'll get a quick rundown is kind of how this thing works. Is you've got this piece called the mater, I guess, that is the rule out here that breaks up your degrees around you, your circle, and then you have another fixed piece that's going to have this ecliptic ring that's going to break up sort of the path of the sun between your tropics, Tropic of Cancer and Capricorn here. And you've got this, which is called they call this, not the rule, it's the index, and this will be the position of your sun as it's coming around. It'll be fluctuating back and forth between the tropics. And then you have your back here, the drum. So this is all fixed. The drum back here, you'll see, this makes more sense once you change the latitude of this. You can see how notice all of the positions of the stars are going to remain fixed, and you've got these pointers pointing to specific stars, but you've got this sort of lattice in the drum here that's going to help break up the sky depending on your latitude to help give you reference marks. So as with the stellarium, when I did that video playing with stellarium, we can simplify this by looking at the drum in a couple of different positions. So we can look at it as if you were standing at the equator. You're standing right here at the equator, and then you're going to be using this instrument. Or we can look at it as if you're standing on the pole, the center north pole. And what's interesting is this ring right here that they call the reet or the net, as it's affixed to the tool. I'll move this in a minute so that you can kind of see how this works looking at it snapshots from day to day, but just want to point out that the center of this ecliptic ring is going to be pointing to a particular place in the drum right here, and that's when we look at it from center north. These lines right here, they're going to be basically perpendicular to each other, depending on which position you're at, center north or at the equator. But from the north, we can sit here and count. We know that the equator is 0, and we know that Cancer right here is going to be 23.5 degrees. So that makes this line right here 25. These are increments of 5, so this is going to be 30, 35, 40, and we see that the pointer is pointing somewhere to some place. There's no specific star, but in this sort of constellation Cygnus right here, that's Vega right here, I guess. But it's going to be 42, between 40 and 45, so right around 42.5 degrees north is where the center of this ring points. And of course, when we look at it, we're going to take and move this all the way down here to this other latitude. We'll see it's the same. Here, our lines are going to be increments of 10, so it's going to be 0 to 10 to 20, and then we know 23.5 is hitting just before the halfway mark here. So then we're 30, 40, and then before you get to the halfway point, you see the pointer is landing somewhere between 40 and the halfway point. So no matter how you set this up or with whatever drum, this pointer is always pointing to 42.5. And so I got to thinking, well, what's special about the point that this thing's always pointing to? There's a constellation Cygnus, I guess, in here that has the it's got the northern cross in it, and but you know, that exact point of where it's pointing to seems significant to me. So I started looking at this and trying to better understand how this functions to the norm, because we see that this is compressed. So this works because of this stereographic projection. And you know, they don't get into the mathematics of how this is happening, but you'd have to look at you would have to be looking at Ptolemy's work of the equant to kind of get to understand the mathematics of this, of how you're seeing the center point. And there's a good video here, this Kepler's Astronomy right here. If you watch this video, this whole series is pretty good and they're pretty quick, but it gives you a pretty good understanding of how you're you know, he's noting, you know, way back when Ptolemy's doing this, he's noting that, you know, kind of you know, the position as seen in the center of distances, but then the center of motion. These are different things, and he's having to rectify this with what's called the equant. But you can, you know, the different in the equant as far as these, the harmony of these spheres. But you'll have to go look at this and kind of study the mathematics of it. But you can look at that entire series there. What was I getting down? Lost my train of thought. At any rate, you'll see how that stereographic projection, it basically compresses this all the way down into the north, because what you're doing is you're taking these 2 points and you're rectifying this so that you're seeing them in one. So you're simplifying it for the device, which is pretty genius. But that's why it's compressed, and I would bet that these have some in their breakup have some sort of relationship to phi somehow with compression. But I don't know that what the ratio of change is for these equal. Like this is 23.5 degrees, as is this 23.5 degrees. But you know, the width of those I haven't fully measured or whatever. But just to kind of get an idea how this thing works, we'll set this up to try to get to midnight. We'll come up here to about 20 seconds, and then I got to click this 3 times fast, and we're 4 minutes off of midnight. But this will help you. You know, this tool is pretty cool because it'll help kind of show you the drift that you have. For one, if we just want to focus on the sun, the position of the sun, and again, we're watching from, this is the equator. We can watch this from the pole. Perhaps from the pole it would be easier. But yeah, we're watching our midday sun, and then we're seeing how it's, or the midnight sun, excuse me. But you see that this is going to fluctuate about 7.5 degrees is what your range is going to be on the outside here. And then when you get on the inside here, the range on the sun on your analemma is about 3 degrees is what I could gather. And then you got a crossing that always happens at 9 degrees north. And then, so this is your analemma, the movement of the analemma. But this also helps you see, because we're taking a snapshot picture of this at midnight every day, which will help us see how the position of the luminaries are falling back. So the slowest luminary is the moon, obviously. Can't even keep up with it. The fastest would be the stars, and then the next fastest would be what you're seeing the least amount of change in. So it would be Saturn, and then it would be Jupiter, and then it would be Mars, then the Sun, then Venus, and Mercury, and then the Moon finally. But pretty handy tool, pretty cool way to look at this. But there was something else I wanted to note. This ecliptic ring, though, you'll see that all of these luminaries, they only drift off of this ecliptic up to 9 degrees. And remember that the crossing of our analemma takes place at 9 degrees. So this got me thinking, as it's telling you right here in the ecliptic ring. right? None straying from it by more than plus or minus 9 degrees. So what I did was, again, I'm pulling up a, excuse me, I got the wrong spreadsheet. Pulled up a spreadsheet to check this out with how this is working. So anybody that's seen my other videos will know that we already find in the breakup of the camps, when we're laying all this out, we know that we set Reuben right here at south, and then we know that Zebulun and Issachar together, these add up to 111,800, and that leaves this 39,650 as this southern portion of Judah until you get to that east compass line. And this is giving you this 39,650 that boils down by least common multiple of 50 to 793, and it's 23.5 degrees. And then we find that this 23.5 degrees is equal to 5 squared times 9. And all of this comes from understanding that this grouping, this given grouping of man right here, without the finding of Levi, is going to be equivalent to 150, and that this is the 1/4 part of Israel that we're looking for. Once you count this, this is the key to unlocking and understanding all this. You can actually find this otherwise, though. Well, you still need to know 90 degrees. So, but once you have that 90 degrees, you'll understand that that's this, and then you can find the pieces of Levi that are missing and how that relates to the eclipse and everything else. But those are, I'm not going to get too deep on that right now. Those are in my other videos. But knowing this, knowing that that 9 degrees then, or that 23.5 degrees, is equivalent to the distance between E and I and E and O here, what I've done is I've just created a quick diagram that'll show you these same rings. So it's from center north, center mass, you'd have the Tropic of Cancer, the equator, and then the Tropic of Cancer, Capricorn, and then that's all going to be centered here on this point A. And then we know that the ecliptic ring right here, we know this is going from, this is a circular travel of the sun that's going from Cancer to Capricorn. So essentially we're just taking this ring and we're shifting it over the same 23.5 degree range. So that's going to give us this other circle offset. And then with that equant, what we find is that that 42.5 degree mark, when we shift this over, 90 minus 23.5 degrees is going to be equivalent to our distance from, I got all messed up here, from A to I here. Well, let's just say 90 minus, we know that 90 minus 23.5 degrees is going to be this figure right here. So we'll see that 90 minus our 23.5 degree mark is going to be equivalent to this number, 66.43 degrees, which we see is going to be, when we convert this into our numbers given for in the book of Numbers, it's going to be 111,800 right here. So we know that that's correct. That's going to be the distance to from there to Simeon, Issachar and Zebulun together. So that's going to be the same distance from B to E here as well. So A to I and B to E will be the same distance. We're just measuring it different, from the center out to 23.5 degrees, or from the equator up 66.5 degrees. But we know that this isn't the center of what we saw on the Astrolabe. The center was at 42.5 degrees right here, roughly. So what we have to do is we're doubling that distance. We're going to double that distance of 23.5 degrees to 47.124 degrees right here, 793. And then we're going to look at the difference of this from 90, and we're going to find this value right here. 90 minus twice the ecliptic degree will give us, that's how we get to that 42.8 degree range, and that's going to be that center right there, the equant. So when we look at this on the Astrolabe, what we're doing is we're compressing this circle so that the center C is going to be right over center B. And that's the beauty of the Astrolabe of how you're getting this. But what this does on this setup on these rings, though, is what I did was I took and I traced a, if I go and find my other tool here, what I did was I took a picture of an analemma, and this analemma right here was, I've rotated this. This is rotated 33 degrees, and we know that the southern solstice is lower on our horizon, and the inner solstice or the northern solstice is going to be higher up. So we know that this is taken, this image capture over the course of a year is taken from the northern or the inner half. And because I've rotated this 33 degrees to get it kind of flat right here, we understand that this is 33 degrees north latitude, and this, I believe, it's San Diego, California, which is right around that mark. So that kind of all lines up. But anyway, what I did was I just took and I just traced this. I took this sort of analemma, and I didn't do the greatest job, but I just sort of traced that. I tried to get it as flat as I could. You do see that there is a sort of, I think I had to rotate this box 5 degrees for it to line up kind of center to the edge. So there is, when you're looking at this all the way across, there is a sort of bend that's happening with the analemma. And this is the globe model thing showing you that kind of 9 degrees north of where it's happening with the crossing. And this would be all your breakup of how you're understanding the relative distances of all of that relating to phi, because we know. Anyway, I traced this, and then what I did was I copied it over onto this page here and rotated it and put it right here center. So I've got it edge from tropic to tropic, and then what I did was, since Excel will allow you to just rotate this easily 15 degrees, I just created 24 different icons of the sun at different times on this, and then you just rotate this, and you see as I rotate this 15 degrees, you're just aligning each sun icon so that it's intersecting with your analemma as I have it. And I don't have this exactly center, but this will give you 24 different pictures, so you can speed this up, and then it'll give you can kind of see how you're tracing this analemma and how you're coming off of your midday period and such over the course, right? So I thought that was kind of a helpful tool maybe for people to see this. But at any rate, these are all the particular points then that have significance. And so what I did was I just took in, I found each one of these different segments by their widths. So the center of all of these circles, the center of this ecliptic circle, once we set it off by that degree, 39 or 23.5 degrees, this would be the center of how it's observed based off of the Astrolabe, that adjusted center, which we see is twice the distance. And then your analemma breakup. So we know that the analemma happens between the tropics, which we know is 23.5 degrees, and we know that 23.5 degrees is the same as phi squared times 9. And this is going to be, when we take this when we take phi, again we get phi by finding the square root of 5 and then adding 1 to this number, and then we're going to divide this by 2 to get our phi number, and then phi times, where was I going with that? Phi times itself is going to be the same as phi plus 1, which is going to be right here. So again, 23.5 degrees, so this is our base value times 9, and then what we do is we're going to divide this, since this is in degrees, we're dividing it by 360 and multiplying it by our known total of the circle of 605,800 based off of the given numbers. And we're going to see that this is 39,650, and that's right in par with what we're finding of that Judah North when we just first lay out the camp. It's off by this small amount right here, but I think that's, that's why we're given such large numbers in the book of Numbers, so that we can make these associations. But so we know that twice this distance is going to be this right here, 79,300. Where are we at? 79,300 is going to be that twice the distance. And we know that this is going to be relative to, if you multiply this by 10 again, this is 52.36. That's going to be your in centimeters, the length of a cubit. So that's kind of interesting that that shows up. But you want to start looking at the breakup of all of these. So since the analemma we know is going to be this total length, and we know that this crossing happens at 9 degrees north, but half of this length right here is also 9 times phi squared. So what we can do is we just reduce this down. We can reduce this down to basically from e to x here is going to be 1, as we see. It's going to be our smallest increment is going to be from x to e. And then from I to x right here is going to be phi. And then I to x plus x to e is going to be the same as phi squared, which is going to be our ecliptic, or 23.5 degree representation. So you're going to see how, and then of course if we multiply, that means that this analemma, the relationship is going to be 1 to the square root of 5, because if this is phi, if I to x is phi, we know that if we multiply phi times the square root of 5, it's going to equal 3.618, which is going to be the distance from the crossing to this part of the analemma. So hopefully this is going to make sense. You could pause this and you can look at all the different breakups as far as what the ratio value is in relationship to phi, and then we're multiplying that times 9 to get our degree representation. And then we can take this degree representation, we can divide it by 360 and multiply it back by 605,800 to get our given, the numbers that were given in the biblical account. Now what we'll find is that all of these numbers that we have here have a least common multiple of 65. So if we divide all of these numbers by 65, this is going to be the numbers that, the base numbers that we get. And of course we see these are all going to be like Fibonacci, the 13th Fibonacci number, the 14th Fibonacci number, the 15th Fibonacci number, the 14th Lucas number is going to be the relative number to all of these different things. And then of course we're going to have some other ones that kind of pop up. 111, of course, people will make note of that with the Aleph and 37 times 3 and the angel number and all this kind of stuff. But just some very interesting numbers that are popping up. Obviously 294, so this distance from A to O right here, sort of the limit of our radius right here. When you look at that, it's going to be 1911, 294. That's the Zadok priestly calendar number. Obviously 294 times 364 is going to give you that where that calendar repeats. So that shows up, of course, 466 and 233. We've talked about that at length with Simeon and everything else. But so, what I did was I did a quick study to see which tribes, if we're adding them together, will amount to some number that is divisible by 65. And of course we've got our census 1 numbers or census 2 numbers. We're calculating Levi in both censuses, and then this is going to be the average. And there are some interesting findings here when you look at the averages of these. Again, 40,500 for Ephraim, that becomes Gad's number, and then the average of that, Benjamin averages this amount as well. So there is some value in here. Ephraim, it's interesting that that 40,500 number is the thing that connects all three of these censuses, or these three values, the 2 censuses and then the average in between. And then you have his other number here, though, is 325, and then that averages to, your 365 number. So that's your yearly number right there. But 32,500 is going to be, that's the length. That is the length from C to I right here. So C to I is 32,500. So that is, when you're looking at one of the base values or distances in here, that does show up in here. So very interesting, very important, and of course that's a multiple of 500. So you can see how when we get into the ratios of these, you're going to start hitting on harmonics based off of that number. The difference between that little spot, so the difference between the ecliptic to that center that we found on the ecliptic range, it's significant in what we're finding in these biblical numbers. But one other thing I think I needed to mention in here, obviously there's a ton to be drawn out from all of this. There's a ton of, these are all going to be all the censuses and situations in which you're going to hit. Just combining two tribes of anything that's going to hit on a 65 multiple, and it happens with virtually every tribe for every census and every situation. And there are some others, because there are going to be some sum totals that you're going to look at. Obviously for the groupings, this is going to be directed to you, but you can look at, just as Genesis is summing up the number of souls relative to each mother. So, I mean, you can look at some of these numbers too, and again, 29, 22, that's another number you're going to see in the relativity between the Sun and Venus. There's going to be a 29, 22 number right there. And of course, that's 8 to 13. You can divide this by 8 or 13, and you'll see some interesting numbers pop up. Where was I going with that? I can't remember. But yeah, again, just a lot of interesting things to be found, and all these different breakups of all of these numbers. So it's obviously going to require a lot of people. I wanted to show the zeta. So one thing that you'll find with the 605, 800, and then of course the quarter of the circle of 151, 450 is another thing Ptolemy is doing when he's doing his breakup of the circle. He's doing this, this is what, 100 AD or something. So there's no trigonomic calculations. So what he's doing is he's building tables. So he's looking at a circle like this, and he's trying to find, like if we were trying to find the chord lengths for all of these points on this circle of this this ecliptic ring, which we see is like 0 to 90 degrees to 180 to 270, right? If we're trying to find each one of these particular distances. So he's doing this on a circle, and he's doing it, he's given an arbitrary value of the diameter of the circle of 120 and the radius of 60. And that's helping him, break it up first at 30 and 60 degrees. And then from there, he's further breaking the circle up into smaller and smaller pieces. And I think he breaks it up until he gets down to 720 segments, or every half degree. But what he comes up with is that when he's got a radius of 60 and a diameter of 120, he finds that the circumference is 377. Now we see that 377 is going to be, that's equivalent to the smallest portion of our analemma, so this northern half from the crossing to the end. That relative number is 377. Of course, that's a Fibonacci number. He doesn't know that at the time, but if you were to divide this number by 120, obviously that's one of the first approximations for pi, one of the earliest approximations, which is pretty fascinating that pops up there. But 377, that's 29 times 13, right? So there is going to be there's other things that you can draw out from this. Is going to be, so we know that pi squared. So another thing that you're going to find is that pi times itself. So we're going to take pi times itself, and we're going to see that pattern of number is very close to 987, which we know is going to be 377. if we were to multiply this times phi squared, we'll see that that comes out to about the same pattern of numbers, 987 and 987. So what that means is that the total of our circle, or the radius, is going to be relative to pi as well as phi, which is pretty cool. And then you're going to have the zeta function. So the zeta function is going to be pi squared right here, and then if we were to divide this by 6, that's going to be the zeta function, and that's got to do with the cardioids, sort of, and this has to do with sort of some of the retrograde motion that we see with the luminaries as well. But that's right here. So what I did was I took that finding of pi squared divided by 6, and then I multiplied it by 9, and then what I did was I converted this into the number that we should be getting for the, what do you call it here, for the numbers that were given for Israel in the Bible. And what happens is you get this number right here of 24,912, and that is very close to, if I was to look at the circumference of the Earth on a globe model. A globe model circumference of the Earth would be essentially the circumference of the equator. So 24,902 would be your circumference at the equator. But what was I lost my page. I lost my page. What the heck is going on? Uh-oh. I'm going to have to cut this part out. Numbers tool. Okay, yeah, 24,912. So you saw it was like 24,901 for the circumference at the equator. Or on a globe model, it would be the whole thing, right? But we know there's trouble with that when we start to put stuff in motion. We start running into a lot of problems, and you're going to have to make a bunch of leaps of faith in that model as well. But at any rate, so what we're going to do is we're going to just divide this now. We'll divide this by our pi number, and then we're going to divide this by 2. And of course, 3965, it's kind of funny that 3965 will pop up as a relative number here again. So 3965 again, that's relative to the number 39650 that we're getting for the ecliptic range. So that's also going to pop up when we look at apply the zeta function to the same way we did with 39,650 being relative to phi squared times 9, converting that into a number relative to 605,800. When we do that, that number happens to be in miles. The radius would be the radius of the Earth in the globe model, or the radius of the the circle of the equator. Equatorial circle radius would be 3965 in miles. So again, another interesting find in here. There's really a ton of stuff to be found in these numbers. It's kind of overwhelming, but anyway, I hope everybody enjoys this. I'm sure I'll have more to elaborate on this, and there'll probably be a second part to this once I start associating some of these other pieces, such as I should probably mention before I get out of here that there is some other connection to when I'm looking at what was that. I'm trying to think what section that was. So some sequence numbers. So there is some connection when you're looking at, I won't get too far down in this with the Lucas numbers and stuff, but this all have to get put together in another time. But just know that 1317 and that shekel count of 1365. These are all kind of relative when you get into the sum sequences of the Lucases. So a sum 7 sequence produces, again, your 11-8. This is going to be numbers that hit on your finding for Levi, and then the eclipse of 40-70 and 65-85 being relative by phi. And then over here, when you get way down the road on a sum 23 and a sum 24, you'll see that sum 24 is going to be a Fibonacci sequence times 720. And that when you go one step back, you'll see how this is relative to basically a nested function that produces 1317 and 2236 sequentially. And also you're going to get 644, Dan's number, and 521. You're getting a bunch of these different numbers, but just know there's going to be a Fibonacci number sequence times 720, and then at the 12th Fibonacci number, what you're going to do is, working backwards, you're going to add your Fibonacci or your Lucas sequence, add and subtract it back through to arrive at that sequence that we found at a sum 23. And of course 521 is going to be relative to 233 by the square root of 5, because he's a 13th Lucas number, 13th Fibonacci number. Anyway, that's getting too deep into some of this number theory. The main point I wanted to show was just going to be the relativity of that, again, that, what do you call it there? Of this astrolabe, and just finding it, some of these relative distances and seeing how evenly this breaks this up, and it's all relative to least common multiple of 65. Again, that's Adonai. It's going to be, one of our names. So, hope you enjoyed that, and we'll be seeing you on the next